If you're interested in listening in all of the geeky things that data scientists get up to, then you want to check out this conversation that I have with my friend Owen Flanagan. In this discussion, we talk about a ton of different things. Everything from the relevance of Excel and VBA in data science, R versus Python, lessons that Owen learned from co-founding a startup, insights gained from analyzing Donald Trump tweets, different types of operating systems to cloud computing. I really enjoyed this conversation, and there is a ton of great content here. I think Owen and I talked for nearly 2 hours or so. So to make this easier to access and get to the different types of information that you're looking for, I've added timestamps in the description below so you can jump straight to the part of the conversation that you might be interested in finding out more about. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos. So to give you a little bit more background, Owen Flanagan is a data scientist working with IoT devices in the water care industry. He earned his master's degree in analytics with first-class honors from the Auckland University of Technology. He's a frequent blogger, a speaker at various data science conferences, as well as a startup co-founder. I have a lot of friends who are interested in startup and tech, so I started our conversation by asking Owen about the lessons he learned from running a startup.
What a lot of people don't realize, which is kind of crazy, but a lot of people don't realize is that startups are businesses. It's a startup business. So there's a lot of people, and I was one of them, who kind of thought, it's just about getting investors to do your cool thing. And we were trying to make drones, like a small kind of portable drone for kind of the mass market. Didn't really get sales. Just didn't really understand how that whole worked, the whole thing. Talking to investors, and some of them were quite interested in the concept, but they were like, well, how are we going to get a return, right? Because they're investing for profit. They're they're doing it to make money. It's their business investing in you. So that's the core thing, right? Of startups is that it's about creating a new business. And usually we see these huge successes like Google, Amazon. And what they were is they were extremely effective businesses. Like Google, right, is provided this technology search, which makes all the world's information accessible. You want to know something, you Google it, right? You're writing code. If classic thing, learn to code. It's one of the top things that I put in my blog post. It's learn to search, use Google, because it's so powerful. And that's what Google did, right? Google gave us that as effective thing with the PageRank algorithm and now a whole bunch more stuff. They unlocked that potential and generated huge amounts of value, which is why they became a super, valuable company. Amazon just built really good e-commerce. This is what they do. They just sell you stuff that's cheap and it's delivered to you quickly, and they have good customer service. That's what Amazon does, right? So it's a really successful business. So yeah, that's one of the core things I learned. But then on top of that, I kind of spent a few years getting to know business. And the key things are the customer, get to know your customer. The customer really matters. Making them happy is the core of things, which is I learned to communicate in sales. Which is really important, communicating your message and having a brand, which is useful for any kind of student, anyone who's it's a job market, right? You're looking for a job, you're kind of selling yourself, the business is your customer. So getting to know them and building that one-to-one relationship, the value of relationships is pretty important. And then just having a good product and the ability to execute. I really wouldn't recommend someone out of university, in the university, to try and drop out and start a startup. If you've got an idea so good that it's that people are giving you money for it, now, and it's taking off Facebook, you've just heaped hundreds of thousands of people are using it, then yeah, clearly that's better than doing your degree. But really, a few years in the business world will teach you a lot. And yeah, startups are hard. Like I've worked, and it's a pretty rough world. Like if you're thinking of joining a startup, they can be pretty cutthroat. They can, you might get a job working on a really like loose contract where they can drop you at any minute. I mean, it's not really the message most people want to hear, but that's like the thing I tell you is that you start a business. People start business because they want to own a business and make lots of money, and that's like, if that's your goal, then a startup's like can be a really effective way to do that. If you've got like a valuable problem to solve and you've got a good solution, like if you've got a good solution for the problem and you can like get that to market. Like I did a startup after leaving university, but also when I was doing my master's, I did some wine sales in China, and I was looking at starting up a wine business, doing some interesting stuff with tech to kind of as like a sales channel. But the key lesson is like doing business in China. What people say to you is, you should really make your product cheaper. Like it's about getting these costs down, but also you realize that the person, when you're dealing with these middlemen, the person who has the end relationship has the power. So the person who has the end relationship with the customer is the person who has the power, right? So that's like an applicable lesson to life, right? If you're in the business world, find out who like is important to you as a customer. Like if you're working consulting, like obviously that's a customer. But if you work just in an office, then it's about like the CTO maybe, or your manager, making them look good and making them, feel happy. What's their motivation in making that happen? And there's a bunch of books on. That kind of stuff. But they're the kind of the key lessons from startup and sales.
Cool. Yeah, no, I think there's a ton of really great advice there, actually. So I think for probably most people who aren't necessarily thinking of entering a startup themselves, I think one really useful thing that you said is basically that the soft skills are really valuable. So for a lot of people getting into data science, like you mentioned, sometimes we get into something like data science because we prefer to spend time hacking away at a computer and making things automated and all these kind of things, as opposed to necessarily going out and networking and talking with people. But those are actually also really, really useful skills, because at the end of the day, you need to find out exactly what are the problems that need to be solved, and problems need to be solved for people, right? And so some really, really great advice, I think, that you've given there. Now, a couple of other things that I thought were really useful that you said as well. First of all, unless you have like investors knocking down your door, basically, unless you have some sort of traction, it's very difficult, I think, to achieve something. And so I think traction is something that's really key if you want to go off and do something. These days, it's not really about having the best idea or anything like that. It's really about the execution of that, because these days information travels so fast that all around the world, like, people are coming up with the same ideas all the time. But it's really the people who are able to execute on those and get traction, I think, is what really makes the difference. And finally, the point that I think would be worth to expand on a little bit more, because I know we've had conversations about this in the past, is really getting effective return on investment. So, when you have a company which undertakes a data science project, what are the different things to consider, like cost of data and different things like that? You want to maybe expand on that a little bit more?
So no one's ever going to give you more than they expect to get in return. And like, people's perceptions of value might be, wildly different between people. Like, some people might look at a piece of art and think it's worthless. Some people might think it's worth tens of millions of dollars. But perception of value, no one's going to give you more than their perceived value. So that's like a thing to consider, is how much value are you giving to the other person? And like, in the labor market, which is a market, you're selling yourself to a company, you're selling your time to a company, and they're giving you your salary in return, or however you're remunerated. So they must expect to get more money from you, all the same, than they're getting, than you're giving them. So you've got to generate the most value. So if you've got a high salary, you've got to be able to like justify that with actions. Now, at different times, that can be different things, right? Like when there's AI hype, it can make someone look really good to have someone working in AI for them. And we just came out of quite a hypey time when people, like a CEO would announce they had an AI initiative, and then the stock would go up by 10%. And if you've managed to drive up someone's stock by 10% by just being there and like writing some Python, then you're worth a lot of money at that time, right? But as soon as that bubble breaks, we get into a kind of a cash constrained situation as we are at the moment, where you're not really generating much value in that way. And there's other things like perceived value, where there's a lot of uncertainty in new things. So it can be hard to kind of work out how much value you're delivering. So, there's a lot of speculative stuff. And again, that will kind of fall apart when kind of people start hunting for cash. And then there's what you've really got to be doing is working out what you're doing that delivers value. Like, what is it you do? Like, you should really be justifying yourself, I think, and kind of making that your kind of true focus is delivering true value and working at how you can do that. And there's a number of ways you can kind of measure value, I guess, or like deliver return. I mean, one of the easy ones is like saving the company people's time. If you can just like, cash is king, right? Cash is prices and money are like fundamentally a measure of value, right? They have multiple, money has multiple kind of exchangeable use cases, uses. It's kind of a weird technology. Like, it's used for like capital allocation. It's also used for consumption, which causes some issues, right? Like, people get upset with billionaires because they could theoretically like buy up all the food, but that would like distort the food market. I mean, I don't want to kind of confuse things here, but money has these multiple uses, and the key thing is they can measure value, and that can be kind of confusing for people who haven't like thought long and hard about the nature of value, right? But fundamentally, if you can measure the impact of your actions in terms of dollar changes, you can deliver return. Like, salespeople can be extremely highly remunerated, and a lot of that is based on like commissions or targets, right? So if a salesperson turns up and they sell, they increase sales by $1 million, or like $100 million, let's say, it's pretty easy for them to like justify their salary, right? And like take a cut of that. And it's like, well, then it's a negotiation about how much they take. So that's a really easy case. Like, sales is a really easy case of like justifying your value. So if you work in, say, marketing analytics or sales analytics, if you can identify opportunities for sales, it's very easy to identify value. If you work in like optimization, operations research kind of things, or any kind of operations environment, operations research, really, and you can like find cost savings, well, that's another clear value delivery. But then it can get kind of hard, right, when it's just like providing information, and like it gets into like making better decisions. So like, how much value does knowing the details of knowing what's going on in like a digital twin, how much is that worth? And then you look at things like people's time. So someone's currently having to go look at this thing, and work out how much time they're spending to get that data, and then you kind of collate it in a new way, and that's some value, right? You're saving people's time. And then they get to these problems. So there's very clear cut cases where you're increasing revenue or decreasing revenue, and that's like clearly measurable. And that, like, it's pretty clear cut. And then there's this gray area in the middle, especially around like finding new data. And I think that's the thing. Like, maybe it's not delivering value, right? If people are just collecting data for the sake of collecting data, then that's a bad strategy. Like, there should be an end goal with like a purpose in mind. So if you're, it doesn't have to be cash. Like, if you're a business, then obviously, like in America, it's your job. Like, you can't not be maximizing shareholder value. And in the UK, I mean, in America, that's like it's the law that companies need to be doing that. But if you're like a non-profit, it could be like delivering some value to society. that you can measure, right? But impact, like cache is the easiest way of measuring impact. But yeah, I
Yeah, I think
think
that makes a lot of sense. So, I mean, effectively, you either need to increase revenue or save cost. I mean, I think those are fundamentally the two big things. But then there's lots of different routes to that, and effectively, you need to link it back to that, whether it's kind of short term or perhaps longer term strategic goals. And I think that in terms of collecting data, like what you're saying about, you really need to be collecting data for a purpose because, I mean, these days it's very, very easy to collect data. And I guess that's what's quite exciting about the technology and in the terms of there's a lot of things that we can do now, which we couldn't do before because it's much easier to effectively digitize data. And, perhaps you could talk to this a little bit more because I know you've got a ton of experience in like Internet of Things and different things like that. But these kind of devices allow us to collect data that we effectively couldn't collect before because you had to get somebody to go around with a pen and paper and like write these things down or whatever it was. But in saying that, it's probably also worth to talk about. We were talking about the cost of data, and to make a lot of these things possible, you need to collect data. And if that is the cost of doing business, then you kind of need to figure out what is the return on investment on your data, which means what do you actually hope to get out of collecting this data in the first place, and then how much does it actually cost to collect the data? Because one of the things that we were talking about earlier was that people seem to think that data is free, and that's far from the case. So perhaps you could talk a little bit more about that.
yeah, sure. So there's kind of two parts to that, right? There's that you mentioned. So the first thing is um, it's easier than ever to collect data, and yeah, that is true. And the second is that that new data isn't free, which is I believe that as well. So yes, it's easy. It is easier to set up collection. We have we have new communications, we have new batteries, and they're kind of the advances, right? So it's relatively easy to put together. It's relatively cheap to put together a small sensor, and then we can send the data back, and you can get that updated daily, minutely, basically whatever frequency you want. And that's great. That's exciting, and we can use that. But that has a cost. Just that unit has a cost. The Wi-Fi has a cost. I think there's also a hidden cost that people don't think about, and that's like setting it up, like configuring like each sensor you have has to be correctly configured, right? And when you're talking about thousands of things, that's thousands of like rows in a database or settings in a computer somewhere. Like that's a lot of things that have to be correct. And then those sensors they fail. They're not 100% reliable, right? So they have an error rate, and then that error has to be like monitored, and you have to capture that, and then you have to go deal with that and maintain it, right? And I think that's just something people don't think about. Like I speak to a lot of people who kind of think it's the same. If you're setting something up, you might as well do 1,000 things instead of 100 things, right? And so I'm thinking about it. So I have this. I think basically there's like complexity, volume, quality, and time are like these related things. So like the volume is, volume and complexity might be the same thing. I'm still kind of thinking this through and trying to understand it. But basically, complexity and volume are like the amount of data and configuration required. Quality is how good a result you're getting, and time is how much time you put in. Time is money, right? Because you're paying someone to do it. And I'm trying to think of a situation where you would ever want more data that was unreliable, right? Like, would you ever choose more data that had like a 5% error rate, or would you want a small, tight, focused bit of data that was reliable, right? and I'm not sure that you'd ever opt for the bigger thing.
Yeah, I think that makes a lot of
Unless,
sense. That's a really, really good point that you make there, because a lot of times these days people often talk about just getting more data and how more data makes it better, but that's not really necessarily the case. I mean, effectively, whenever you're doing a data science project, what you're doing is you're wanting to pick up a pattern, and so in order to pick up a pattern, I mean, you need like a sample of data which is representative of what you're trying to achieve. So you want to capture the variance and everything like that you would have in different situations, right? But the data has to be of a certain quality, and if the quality is not there, then you spend a lot of time basically cleaning it up, like filtering it out, figuring out what's good, what's bad, and just getting rid of a lot of stuff. Actually, it actually creates a lot more work than it provides in value. So I think that's definitely a really good sort of message for people to pick up on. And I guess the other thing that I'd probably add to that as well is that, although, like you said, it's a lot of the technology is relatively cheap now. Like storage is relatively cheap. I mean, we can store and process petabytes of data now with all the big data technology that's available. But it's not like that's without a cost. So, every time you add more data, there's going to be more storage cost and more processing time. And even though that's relatively cheap, it adds up, and it can add up quite quickly. So the real question is what data and how much data do you actually need for the question that you're trying to solve? Would that be a fair summary?
I think it's a question of strategy, right? Jeremy Howard does some great courses, Fast AI, and he's got this philosophy called like the drivetrain method for building like data products, which I strongly recommend everyone look up. And the basic principle is that, what some of the foundational ideas are that he's big on machine learning. He was like chief scientist at Kaggle, but basically you can use a machine learning model is not just a predictive model. It can also be interpreted, right, to understand the data. So it's like an analysis tool. If you have like a bunch of data and you want to predict something, first thing you do in his methodology is you do build a basic model, do some feature selection, and work out what your top features are that really like that really best kind of allow you to like cut up your variance, right? And then you work out, how do we measure these things better is part of the process. But all of that is kind of is based on the idea that you know what problem you're trying to solve. So you need to start with a problem, right? And Einstein has a saying that I can't remember word for word, but basically it's, if he had a problem to solve, he'd spend 50 minutes. He didn't know how to solve it. He spent 50 minutes thinking about the problem and 10 minutes thinking about the solution, right? So like the problem is everything, the intent is everything, the need is everything. And then it's about working out what the best solution is. Like Steve Jobs, described a product as like a compromise, right? So you're trying to deliver products is how I look at things. And you're trying to find this best compromise to solve the problem, given the tools you've got, the time you've got, the resources you've got, and the kind of the expertise you've got. And you're just trying to find the best kind of optimization in that space you can. But that it's having that true north that you come back to of what the problem you're trying to solve is, and how you're going to measure that, or like what the impact is, right? And then working from there, like what would actually help us measure it, and then you can like experiment, right? There are many I think it's in this innovative space, right? And like one of the techniques you learn in the startup world is like the lean methodology, right? So you start with like a minimal viable prototype, or like a minimal viable experiment in this case. You do the smallest thing you can to like test your preferred solution, and then you learn from there, and then you iterate, and then when you get it good, you kind of scale it up. And I think that data science is like an innovative field, right? Like we're trying to find new solutions to problems using data. That's kind of a way. That's one description you could use of data science. Another's like the science of dealing with data, but that's so broad. That's nearly computing, right? There's a description of computers like computing is data and algorithms. Like that's a description. So it's like half data science is then processing data is just computer science. So I think that a useful way, especially in the business world, is and one that's influenced by my background in startups and in business, is that it's about finding new solutions to business problems using data.
Yeah, no, I think you got some really great points there. I mean, as you mentioned, there is still a ton of innovation in the field because, a lot of the stuff is really, really quite new. We're still figuring out exactly how we can use the technology for different things. And, science is basically about coming up with hypotheses and running different experiments. And we can do a lot of that with data now. We have a lot more tools to do that because we can measure a lot more things, and we have just much more effective tools for exploring larger data sets, which do a lot of the manual work for us. And that's, I guess, what you get out of machine learning a lot of the time as well is, run a model on your data, extract the feature importance, different things like that. Start to see some of the patterns and test some of your hypotheses to see, do these things make sense, and then refine from there. So yeah, I think very much an iterative process. So just switching gears a bit. Now I know that so quite a few people who could be listening to this come from a background where they might be using a bit of Excel and VBA. And I know you actually have quite a bit of expertise in those areas as well. So I wanted to ask you what your thoughts were on, I guess, the usefulness and relevance of tools such as Excel and VBA when we have newer tools such as R and Python these days.
Yeah, sure. So Excel is the best spreadsheet, right? And the spreadsheet is like a fundamental tool in data, in the data world. Just being able to there's no tool that I have found that is as good for editing like a random. It's like human random access data thing, right? You can just click on a cell and then enter it. You don't have to find a reference or do anything fancy. There are many ways of doing it. To change a thing in R, you do column and then index, right? Or similar in Python, you can use just coordinates or any kind of array. But clicking it's the most kind of random access from a human perspective data entry tool and data manipulation tool you'll get. That's sort of a bad thing. It can lead to bad habits. But for making a few changes, for looking at things and understanding what's going on and just looking at your data. If you've got a big amount of data and you just want to look at it, a spreadsheet's really good for that. In terms of analysis, there's some really powerful stuff in there. But I find it's really useful for just checking for differences and checking your work, which I think is something I'm really passionate about at the moment. Just being able to, there's simple things like just checking if two cells are different, two columns are the same, and it's looking for differences. So you pull what you expect and what you want, you just run that, and then you can just color it with a conditional formatting button, and then you've got a column of differences, right? There's a few clicks. That's just really useful to have. Excel is just a really useful thing. You can do quick plots for small amounts of data that aren't too heavy. It's good. So that's kind of Excel. There's lots of quick checks you can do. Text editors are also awesome, right, for that kind of stuff. But Excel spreadsheets have a special place. Then on top of that, there's like a lot of the modern technologies. Excel has Power Query built in, so if you're using Power BI, that can be useful. Power Query can read like really long files or hook up to SQL. So you can read a really long file over 1 million rows, which is like the limit for Excel, and then you can like pivot it out. So that's like some powerful stuff in there. It's also a really good learning tool, Power Query. There's a kind of a piece I'm kind of fleshing out at the moment, but basically there's a kind of common core. There is a framework of data manipulation that is like the core of, say, SQL and like dplyr and R. But there's a set of verbs you can use to manipulate, to filter, to group, to summarize, to pivot. And Power Query has all of them in a clickable interface. It's not particularly performant, like it can be really annoying. It has a programming language in there, like Power Query M language. So if you're kind of intimidated by programming, you've never programmed before, you work in Excel, you can still like start to pick up things like joins on tables, right? Joins are mind-blowingly useful if you've never used them before, but you can join 2 tables in Excel. That's great. So that's like a perk. And then once you get to know and think about that, then the ability to write it down in R or SQL, you've learned a lot of the mental skills you need. Then it's just writing, learning the syntax and learning to code. VBA is, I think, useful for data entry. That's like the key thing I think it's for. Like you can pull data into Excel using it, and I still see people doing it. But I think the key thing that it's useful for is getting Excel data into something else. And you can do that with an R script, right? Or a Python script. You can read data and then like push it into a database or something. But I think VBA, you can package it. You can get it through like firewalls and stuff. People are used to being able to deal with Excel files. So the ability to like press a button and generate, like a set of inserts for SQL, just directly dumped to a database. If you're comfortable just dumping data directly from Excel without like watching what you're doing and monitoring the transactions. I think VBA has a lot of uses there. I personally wouldn't really use it. I wouldn't really recommend using it. I personally don't want to use it. Basically, it's not that I don't recommend. I just don't want to use it for data analysis. Vectorized code is just way better. Like, why should I have to write a for loop to loop down? It doesn't have functions, right? Well, it has functions, but it's not like a functional language, so I can't map anything. Like dplyr is so much better. Like pandas is better. Like VBA is it's an old school. It was good when it was invented, and it has its use. If you want to automate workflows, if you want to send heaps of emails, it's still pretty useful, right? But for data analysis, for data processing and like lightweight stuff, for augmenting Excel, yes. For data analysis, no. You should learn R and Python. If you can already write VBA, then you should learn R or Python. And even just to learn functional programming, right? There's no bad computer language to learn, right? So, and if you're already like proficient in VBA, then it shouldn't be hard to pick it up. And when you discovered, like, if you pick up R and learn dplyr, like learn the tidyverse dplyr and like ggplot, your mind will be blown. The ability to just generate these beautiful plots and then turn that into a function and just plot it over an entire like folder of text file of CSV files. Try doing that in Excel. You can generate heaps of images and you can do it, but it's so much less powerful than modern. Like R and Python is so powerful.
No, absolutely. I think that makes a lot of sense. I think there's a lot of good advice there. So actually, I do teach some courses and stuff as well on Power Query, because I think it is actually really beneficial for people who don't necessarily want to code, or are not quite at that level yet. But for a lot of times, people who are at the level of VBA, I think that R our Python is going to be like 10 times faster. And for the most part of it, it's going to be like 10 times less code as well. So it's just so much less work to get everything done. It runs faster. And, like, as you mentioned, functional programming, maybe, that's probably something to discuss another time, but it's a beautiful thing. It's a really, really nice. And basically, something like R or Pandas for Python, they are analytical tools. I think one of the things that people don't realize about something like VBA is that it's not an analytical language. It's a language, as you mentioned, for augmenting Excel and other Office products. So to do things like, if you want to move cells around or resize things, or as you mentioned, sending out a bunch of emails through Outlook or something like that is a really good use case, because VBA will give you direct access to those, to call those functionalities of those programs. So I think that's where VBA is useful. Other little things, like, for instance, like if you have something horrible, like sometimes people might do something like color code values into cells, which is not something that you can read into another program. But VBA can be used to extract those colors from a spreadsheet and then codify them into a number, so that you could use it in your analysis, right? So I think there's definitely use cases there. And hey, if it's the only thing that you have, then maybe it is a useful thing to do. For the most part of it, I would say, if you have Power Query, use that instead of VBA wherever possible. And if you have access to R or Python, and you have the capability to write VBA, then definitely check those out. Instead.
Yeah, and I'd just add to that. Yeah, I mean, if you've got access to Power Query and you don't want to leave, I mean, Excel, like the next level of Excel in that direction is like Power BI, right? Which is also like a valid way to go for like visualization and stuff. So, but like working, you'd be doing your work in Excel and work in engineering. A lot of people, like, I had someone ask me, is the foundation of your software Excel? So you should not underestimate the power of Excel.
Yeah, no, I mean, Excel, I mean, it's had millions of dollars invested into it. It is a very, very powerful tool. And although it does have its pitfalls, like, I think there are a lot of, basically, if people who knew Excel learned better data practices, it would make life easier for a lot of things, because a lot of the work that comes with data, going back to the conversation about data isn't free. When we collect data from spreadsheets, sometimes that's sometimes for like a data scientist or an analyst or someone, that can be an incredibly time-consuming and expensive process, basically because the data is bad. Annoyingly, Excel has a bunch of different issues with it as well. Like, it corrupts data when you open it, like it drops leading zeros, it messes up foreign dates, and all these kind of things as well. A lot of those are fixed if you use Power Query. So again, another reason to definitely learn Power Query if you're doing that. And Power Query, as you mentioned, is transitions very naturally onto Power BI, which is a great tool for data analysts and people getting into business intelligence. And although, like, I mean, you can do those kind of things in R and Python as well, but really the reason why you would start to move to those tools is not just for BI, but if you're getting into automation, you're interested in getting into machine learning, or even just exploring your data in a different way. Like, when you do have a larger data set, then instead of just looking at your data visually, which I think is something very useful to do as well. Say you're in R, you run summary, right? And then instantly you can see the distribution of your data. You can see all of your categorical variables and how many values they have, and all these kind of things at a glance. And those kind of things are really, really useful. And learning how to look at your data in different ways that can be it can basically be much more efficient sometimes. So
Yeah, I mean pairs, right? The pairs function will just generate a plot
yeah,
of everything plotted against each other. And yeah, like if you want to explore your data, I'd say the tidyverse is the best data, exploratory data exploration framework out there. Um, you just be able to the ability to dig into the data with ggplot, just create those plots really quickly with the grammar of graphics. Um, and then just mutate your way through the data, just piping new functions and new mutations onto it, and then just getting those plots out. And then with new things people are building on top of it, like Plotly, with ggplotly, so you can make it interactive, so you can hover over the points. Um, yeah, there's some great functionality there, and then you can just wrap that in a dashboard, right, with Shiny at the end of it. But yeah, I mean, try histograms, the ability to
yep,
just create a histogram, but then that's that level of understanding, right? To use these statistical tools requires a level of learning, of knowledge.
yes, no, absolutely, it definitely does. But I would say that the tools really can help facilitate that education as well. Because if you start, maybe if you transition over and you're, using bar graphs to start with, because that's what you know and that's what you're used to. After a while, you can start to see the value in some of these other graphs as well, like histograms and box plots and all these different things, which will start to show you that you can't always just take. It's not always enough just to look at, say, the higher number or the lower number or something like that. You really want to be seeing the distribution and the range of things as well. How much, what was what was the sample size, all those different types of things, which do make a difference to your analysis. And so, if you are really keen and passionate about getting true insight from your data, then these things start to make a difference, and these tools can definitely help with the education of that.
Yeah, I mean, I really hated statistics in high school. Like, here's the normal distribution table. Your job is you're going to be graded for correctly picking the right value from this table, right? You get it wrong, well, bad you. It wasn't very interesting, wasn't very exciting. Then you get to just like understanding data, and what statistics is looking at, the way data is shaped, and it can get pretty interesting. So getting a fresh data set, running pairs on top of it, and then looking at the interesting stuff, digging down into it, finding the stuff that you wouldn't expect, and then with ggplot, there's like the linear model you can fit, and you can do some transforms pretty easy with mutates to move stuff. Then you do a plot through it, and you're like, well, is that a good fit? Like, does my intuition hold here? Do these things hold up? And it's I think it's a very fun and interesting way, and it's to kind of understand your data, and yeah,
Yeah,
you
yeah,
can't
no,
do that next out is what I say. Right.
yeah, no, absolutely. I mean, it's definitely worth to learn some statistics. And as you mentioned, I mean, when I learned statistics, in school and university and stuff like that, it didn't really make a lot of sense at the time, how useful it would be. And I think I was really lucky, that I got to work with statisticians, and this is the other thing as well. If you're getting into this field, you want to take a look at and evaluate what your skill sets are. So maybe, say if you're working with Excel or something like that, you're used to looking at the data, you spent a lot of time with it, the data quality issues, what the different metrics are that maybe your stakeholders are looking for, all these types of things. And all of these are useful bits of information that you can kind of bring to the table when working with maybe some other people in the team who have different skills, like maybe statistics or something like that. Now, one of the things I realized was that when I started working with statisticians, is that they weren't necessarily very good programmers. And so these days, because, data science is, in some regards, basically statistical programming, having those skills in programming is a highly useful thing. And so I got to learn statistics while teaching statisticians programming. So that was an incredibly useful thing. So anyway, moving on, I wanted to talk with you about get your views on R versus Python, because I think you have some views on that.
Yeah, I mean, I think I've come out pretty openly as being a fan of R. I mean, R is, I think, the best exploratory data analysis tool and the best statistical tool of the two. I mean, I don't know much about Julia. Like people say, Julia is, like I don't know. I mean, that's like another thing to throw in the mix, right? But of the two common ones, like I think R's is probably a better tool for like data analysis. Python though is a extremely useful programming language. And it has data science tools. It has, for deep learning and stuff, well, all the software engineers are writing in it. I think one of the core things people kind of overlook is that R is like a functional language at its core, and Python is like an object-oriented programming language at its core. Like if you see a Python developer work, they'll be writing classes all the time, right? If you see a Python, an R, programming work, they're probably just like applying functions. And the ability to like meta program in R, I don't know how deeply you've dug into like tidy evaluation. I mean, there's lazy evaluation and things like that, and like promises and stuff. But as you dig into like tidy evaluation and being able to like tie that all together,
it's beautiful. I teach a bit of that actually. I teach a bit of tidy evaluation in some of my courses actually. But I mean, just to zoom out and take it back a little bit for people who may not be familiar with like really what functional programming is. So, now we're talking about things like functional programming versus object-oriented programming, which, as you mentioned, is something that's been used by software developers for a long time now. So maybe we could talk a little bit about, what are actually some of the real nice benefits of functional programming, particularly for data science and data analysis type work.
Sure. So I'm not a computer scientist. So I don't have a computer science degree. So I just want to lay that out there, right? So you should do your own research on these things. But basically, there's two kind of, like functional programming is its own paradigm of computing, right? So there's the classic kind of procedural programming where you just kind of write a loop and you kind of give instructions. And then functional programming is kind of built on the idea of this lambda calculus, but basically it's a function is like a black box, and you put inputs in and you get outputs out, and you can build all the computation on top of that. So that's like some really complicated stuff, and if you're interested in that, look it up. But what it means in practice is functions. Functional R as a functional programming language means it's built heavily around functions and the application of functions instead of like looping, writing loops for instructions and iterating. Like a pure function is like a key issue, like a key concept. So a pure function is always does not care about its environment. So you put input in and you get output out. And so it doesn't care about it doesn't use like global variables or anything like that. So in that way, it's kind of safe, is a good thing about it. It's good for data analysis because it's transformations. Like a lot of what you do in data is maths, right? Data analysis, data science is kind of a lot of maths and stats. So you have a column of numbers and you want to add something to it, you want to multiply them together and stuff, right? So they're fundamentally mathematical operations. Even if it's like text, right, and you want to like concatenate strings together, right? Still, like it's data, so it's like you join.
Basically, you have inputs and you have outputs, and it's very clean cut. And I don't know, as you mentioned, it's for anybody who's interested, it's probably worth looking into it. Maybe an article or something like that. Maybe I'll find one that is useful. to pop up because it's really worth to see it, but it does make it easier to test certain things to see if certain things are working properly. Just another example that I'd like to probably give, because a lot of times one of the key concepts that you learn when you first start learning programming is something like a for loop, right? Now, and so when you start looking at things like functional programming, which use something like a map function instead of for loops, it's this completely different concept. But once you get it, it's this really beautiful thing, because what you realize is that when you're writing something like a for loop, effectively what you're telling the computer to do is do this step, and then do it again and again and again, and it basically say you're looping through the numbers, say 1 to 10, right? It'll go number 1, number 2, number 3, number 4. And you're very explicitly telling it how to do that. Where a lot of times when you're working with data, you don't necessarily need to run the data in a sequence, right? So maybe you just say, instead of doing item 1, say you have a function called make this thing red or something like that. Instead of going from item number 1, make this red, go to item number 2, make this red, go to item number 3, make this red. What you're basically saying is just make all of these red and just go off and do it. And I don't care how you do it. And by doing that, the underlying implementation of how that's done can be done in lots and lots of different ways. You could basically, and this is where you can get into things like parallel computing. You could send off a function instead of having to do one at a time because it's all being done on one computer. You could basically say, make all these red and distribute this across 10 computers, 100 computers, and have that process parallelized. So that's one of the things that's really nice about functional programming. So these are, if you've heard of MapReduce for like Hadoop and everything like that, that's a functional programming concept, which is brought to things like R and is actually used very commonly within the language to be able to do those kind of things. So it's able to, basically parallels operations, and because it doesn't need to run stuff in a certain sequence, it can do stuff faster than necessarily looping. So some interesting things there.
And that's an excellent explanation. I think it also, the other thing is with functional programming is like function generators and stuff, and you just get some really beautiful abstractions, which are useful for specifically for data science, which is where tidy evaluation come in. And if anyone wants to learn a lot about functional programming, the language to look up is Haskell, which is purely functional. So if you get good at that, that will open your mind to the possibilities of R, really. And then going back to the R versus Python thing, Python is object-oriented, right? And so it's about creating objects which can like, you can define like a type of object and then have like instances of them. So it's like a way of making containers. Like a vector is an object, right? And it has all these containers in it. And that's like, it's a core part of computer science, like object and like of like pure like algorithms, like data structures and algorithms. So it's like core to like a programmer's education and thinking. And I think that a lot of the use of Python in data science is programmers coming to data science, whereas the use of R comes from statisticians and scientists coming to data science. And I think they're both valid. The whole point is it's like the intersection of the two, right? Is statistical programming. They say a data scientist is a better statistician than a programmer, and a better programmer than a statistician, right? Yeah. So I think they're both valid. I kind of think you should learn both. But I mean, yeah.
It's a tricky thing sometimes, because a lot of times you get the question, well, which one should I learn? And like you said, they're both useful. They're both really useful concepts to get. If you've done some programming in the past, like learning a functional programming is this kind of mind-blowing experience. It's a beautiful thing. But learning a little bit more about object-oriented programming and everything is very useful as well, because it is used for so many things. And I guess it really depends on what you're trying to do. If you're more of an analyst, you're digging around the data. If you're coming from an Excel background, these are kind of not, like non-scalable solutions and stuff anyway. Then, I'd say R is probably a nicer, friendlier transition, because it's built for the people who do that kind of work. Whereas, as you mentioned, Python being for software developers and everything, it integrates very well once you do want to scale. And it's not to say that, like R can't be put into production and all that kind of stuff like that, because it can. But, the way that we put stuff into production, everything these days is putting it onto something like AWS. And, basically Python, if you want to write a Lambda function or something like that, on AWS, you probably write in Python, right? If you want to access a lot of the different libraries and everything like there, that's going to be in Python, right? So, I think there's it's definitely a benefit to it there. And as you mentioned, things like deep learning and everything like that, a lot of these things have been built for Python. But it is a very different use case, because, you probably not going to use deep learning on your Excel data, right? So.
Yeah, Power BI, they're putting in some like machine learning for like exploration, right?
Yeah.
But mostly for like getting insights out of it. So you've got these columns, you want to predict this column, or which of these many columns are actually important and how they relate, right?
Mm.
So I wouldn't say, so in the future, it wouldn't surprise me, and that's probably using like some kind of gradient boosted tree, right? Or like
Yeah.
tree-based model. But
Yeah.
I'm actually reading a paper at the moment for a meetup on like an exciting new neural network based application for tabular data. So,
Okay.
I
Well, never
mean,
say never then.
you never say never. I mean, your spreadsheet might not have enough, but a spreadsheet can hold 1,000,000 rows, right?
Yep.
But I think that yeah, that's when deciding what you want to do. Like data science is a massive kind of field. Like there's the data scientist role, which is kind of a catch-all. Like people are just like, oh, we need a data scientist. They don't really know what they need. But if you're working in Excel and you just want to get way better at analyzing data, and you don't have a database, and you don't have huge amounts of data, then R's like a really good way to go. And if you want to pick up some statistics and get some histograms and really understand like a medium-sized data set, like small data set is, my way of thinking about it, small data set will fit in Excel, a medium data set will fit in memory, and a large data set won't fit in memory, right? You need to do some kind of other compute. So if you've got small data, so up to 1,000,000 rows and up to like, I don't know, 50 columns, that's a lot of, beyond that, that's not small data anymore. If you've got that much data, then R's a really good tool. If you don't plan on like spinning up like cloud infrastructure and like building automated pipelines and doing massive amounts of data processing, crunching it to numbers, then yeah, R's like a really good tool. If you think you're going to be working on those kind of tasks, R's still a really good tool. But if you think that you're going to be working on trying to like leverage huge amounts of compute or doing lambdas, like Azure functions, right? Python's just the way to go. People just don't support R in the same way they support Python. So it's like, if you're just working on your desktop or your workstation or your laptop, R and Python, there's no real difference from like a running perspective. I actually think that R is potentially easier to get running, just because of all the packages and stuff. I've had less issues with R, just because it's got those single versions and because you're getting it from the CRAN, centralized repository. But Python, yeah, you can get Python running, like getting Python to run your scripts in like Azure, getting Azure to run or like AWS especially, to get it to run your Lambda is no easy feat even with Python. If you're doing some exotic stuff, it can be tricky, like because you're using AWS Linux and it's not very friendly. It's like this, yeah. I don't want to get into the details of that at this stage, but Python is just not possible. Basically, it's just not supported. No one's planning on you doing it. and Python is there, and then like a lot of the tools support Python. And if you want to do other stuff apart from data analysis, Python's the way to go. You can just write just a general program in Python. I mean, you can make games in it. You can automate a bunch of stuff. People are building versions of Python that run on that you can compile, MicroPython that you compile to IoT devices. I mean, it may not be the best solution, but it's like they're saying something like it's the third best language for everything. So I wouldn't say to anyone, don't learn Python. It's really a question of how much time you're willing to spend learning and what's really important to you, where you are, what are your strengths, what is the best thing you could add to your skill portfolio to achieve your goals. That's the way I'd look at it.
Yeah, I like that. I hadn't heard of that before. Third best language for everything. So I guess that's goes to support the fact that Python's a general purpose programming language. So it's one of the languages that's kind of used for everything. It's not the optimal or best for everything, but it is really used for a lot of things. So it's a very, very useful programming language to kind of add to the mix. So actually moving on, maybe we could talk a little bit about your project that you've been working on, because you're working on an NLP project. And I guess one of the things we're talking about, so maybe you could tell us a little bit about the NLP project, which is, for those of you who are not familiar, NLP basically stands for natural language processing. It's basically being able to analyze text. And the kind of infrastructure that you built up for that as well, because I think that was really some of the key lessons of the project as well.
Yeah, so the project I'm working on is analyzing tweets with the @RealDonaldTrump tag in them. So it's something I started on like a year ago. I did it for a few weeks. I kind of got this application up running. It was the first time kind of trying to provision cloud infrastructure myself and get that stuff kind of running. And it was, Donald Trump was big in the news, still big in the news, but it's been a constant thing for a couple of years. But like a couple of years ago, I was doing some courses on data learning and about learning skills. And one of the things I did was basics of NLP, and we did these word clouds. And I was like, well, I'm going to do some word clouds of Donald Trump, because that might be kind of interesting, right? He just become president. And so I got I can't remember where the data came from, but it was tweets, Donald Trump's tweets from like 2014, 2012, something like that. And then 2015, like over time, I did it like a few years, and you could see well before he was started president, he started his run for president, he was tweeting about Miss Universe and The Apprentice, right? So he was tweeting about his businesses, and then over time he started tweeting about Obama, and then became the Donald Trump we know today, tweeting about politics consistently. So you can see this clear transition over the years. I thought that was really interesting, and I thought that was good enough to kind of base a project around when I was looking for a kind of a topic for some Twitter analysis, because I wanted to get lots of data, just lots of it, that no one else was really using. I didn't want to just take someone else's. I wanted to collect my own data and do something with it. So I was looking around, and Twitter's a really good source of data. The API, they provide free access to there. You just have to set up a developer account. They'll give you 18,000 tweets every 20 minutes, but it only goes back a week. So if you want to collect a large amount of data, you just have to ping it, the API, every 20 minutes and just build it up over a long time. So I picked the Real Donald Trump search query because it was easy, and so I didn't have to learn the kind of the syntax and the query syntax for the Twitter API, and because there was heaps of it, and because it was interesting. And so I built a tool that kind of visualized that, and it did what I thought it would do, which was it visualized the news. Like you could track the news by looking at like word counts. So you could see over time it was talking about this, talking about Russia, and then it was talking about like Supreme Court, and it had, each day would have this person who was big in the news that day. So it was proxy for the news, right? And I'd just come back from China, and so I'd come out of this kind of echo chamber. Well, not really an echo chamber, just state-run media, right? And so they all have state views, and the papers all say the same thing, and everyone agrees with it. And everyone that I was talking to was, getting their news from kind of American left-wing media. I mean, we wouldn't really call it left-wing over here. I don't know what you'd call it, but I mean, we would call it left-wing. But that doesn't mean I don't want to get into that. But, from anti-Trump, we should say, from anti-Trump news sources. And then I, went and watched quite a lot of videos from Fox News just to see what they were talking about, because, I was wondering about these echo chambers. And yeah, it was interesting that how much you would believe stuff, the amount of information you were getting. So getting a huge amount of stuff about Donald Trump, I thought it'd be interesting to be able to identify who was... I'd be interested to see if it was possible to identify who was like a liberal, or like who was a Democratic voter and who was like a Republican voter and who was like not interested, right? So there's still like a lot of advanced text analytic in there. And I've got this concept of bias that I'd like to investigate. But fundamentally, what you find when you start pulling in, 18,000 rows every 20 minutes with like 100 columns, and you're like on a shoestring budget, and you've got this like a tiny database, is it starts to fall over, and you're trying to display this data and it's falling over. So it was just falling over constantly for weeks. And so I just kind of got really interested in that. And like all the fancy analytics, I didn't really get to that first time. And I built a thing and I had it running and stable. And then I shut it down to save money. A year later, I was talking to some people about, potential things to do. There was like a meetup coming up, and someone asked me if I'd give a talk. I was like, sure, I can talk about that. I'll throw that together. So I started it up, re-engineered it with my new skills. It's all built on Postgres, and I've got a lot better at Postgres since I first set that up. So put in some indexes, re-engineered it, and it runs a lot more smoothly. It's still... Yeah, and so I kind of did that bit and changed the kind of the extraction a bit, and changed and then I did a lot of work. So I upgraded the database, and that was fairly simple. That was just adding some indexes and changing some data types to make the queries quicker. Then there was changing the way the compute worked. My original architecture was I had a database, and then I had an Azure, an AWS EC2 instance, so elastic compute. So just basically a virtual server and a virtual database server, because it was easy to get the database up and running. I didn't have to like set up Postgres or anything. So I had this second computer that read the data from the API, wrote it to Postgres, read from Postgres to do the NLP processing to create word counts, wrote them back, then read that, and then delivered that via Shiny server to a website via with a URL. So I got that running, and that was good. For the first thing, I built a website that like processed heaps of data. I built an end-to-end system, and I was kind of happy with that as a first attempt. It took a lot of work, but I was proud of myself. I mean, it was garbage. Didn't work very well. It was super unreliable, but I did it. And then like a year later, I came back to it. So a year later, I came back to it and started again. To rebuild it. So I did the optimizations on the database, and then I basically decided I didn't want like a server, because servers are expensive, and I wanted to save money. So I started out thinking, well, I can use Shiny. I can use the Shiny. Can't remember what the service is called off the top of my head, but our studio provides like a Shiny
ShinyApps.io.
ShinyApps.io. So I use Shiny Apps for the front end, because that's basically free, because no one was coming and looking at it, right? Yeah. I had basically no traffic, so hosting it myself was, not required. And then for the processing, I started thinking I'd use AWS Lambdas, but like I spent like a weekend pulling my hair out, dealing in the bowels of AWS Linux, which is like which is a variant of Red Hat, which uses Yum as its package manager. Like it's all this stuff, which is like, and it's super unfriendly and super poorly documented. And basically, don't do it. Don't go there. I spoke to an AWS solutions architect about it, and he was like, "You don't do that." Someone told you to use R and Lambda and Lambdas. They were joking. Like they were playing. Don't do it. But fortunately, I know some of the, I know some people in the kind of the data science community in Auckland who do use R in production, and and it was Stefan, who you probably know, and he suggested using Docker, and that was way better. You can just take the code you're running on Linux, and you can just put it in Docker. Basically, just build it, ship it with Fargate, and it just runs, right? And so that's what I've got running now. So that's been running since January, whenever I set it up. So I've got to do some maintenance on it soon, because I've got 100 gigabytes data storage limit in the database, and it's going to overfill, and then something bad might happen. Last time the database overfilled, I got a $200 bill over the course of a weekend because these Docker images were stacking up. So I keep an eye on it. Yeah, so that's where I am at the moment. And then it's been a busy few months with the pandemic and disruptions, meaning that I've been hectic at work. Yeah, I'm planning on.
I think it's some great progress that you've made with that. I mean, effectively, you're getting into the area of data engineering. So, this is kind of really the other side of things. I mean, sometimes, you don't know whether it's there's this point where you take your analysis, but then you want to stick it on some server, you want to build up the infrastructure and everything like that, and it starts to become almost this other set of skills, right? So all of these data engineering skills to get things up on AWS, and there's all these different pieces to get it running. There's lots of different ways of doing the same thing as well, right? So as you've mentioned, you experimented with Lambda functions and Docker, and assuming you started with like EC2 and stuff like that. So, effectively, those can be different ways of doing the same sort of thing, and each of those has different cost implications of doing these things, and so there's really a lot to look into and think about. But yeah, I mean, I think you probably made some good progress there. I mean, perhaps for those who are not familiar, maybe we could talk a little bit about the difference between, say, EC2, which is basically just it's your most straightforward service. You have a computer, it runs. But it's also kind of the most expensive way of doing things, because you kind of have them running all the time. I mean, it's probably not the right thing to say that it's the most expensive way to do things. It depends what you're doing, of course, right? But maybe we could talk a little bit about the difference between, say, EC2 versus Docker versus a Lambda function.
Sure. So it's basically a question of server versus serverless, right? So EC2 is like rent a server. And you're just paying for like someone to run a computer for you. EC2 has some things like you get compute credits as well. So it's not just you rent a computer. It's like you rent a computer, but they kind of don't expect you to run it at full tilt all the time. EC2 is super useful for like deep learning on a GPU instance, because you've got AMIs. So you've got these machine images, so you can basically someone else can build like an image for an operating system, and you can spin that up, and that's pretty useful. It's for someone I'd say if you want to get started and you're on Windows, then install like Windows Subsystem for Linux and like learn the basics of Linux, like the Linux commands, and then because you'll need to SSH in, and WSL is way better than PuTTY for like SSH, which is something you'll need to know, secure shell, for logging into these remote servers. if you're on Mac, you already have a Unix terminal. So you don't need that kind of stuff. You can kind of get started and learn some command line and just connect to these servers anyway. But if you're an EC2 image is a server. You rent it. You can get it in a variety of flavors with different amounts of CPU, RAM, and GPU. And that's just a computer, is the way of thinking about it. It's a computer that someone else runs for you that you can promote into with SSH and run some stuff. You can get them with Windows, but if you want to do anything with cloud, you should learn Linux. There's a reason Windows has got Windows subsystem for Linux now. So that's what EC2 is. Then that's a server. Then there's serverless, which there are servers, but you're not renting a server. You're just kind of buying compute. So the simplest is an Azure function, an AWS Lambda, which is equivalent to an Azure function. They're pretty useful. It comes back to this idea of functional programming, right? So you have input and output. They've got a hard time limit on them. They're designed for simple tasks. There's a bit of configuration required to do something like complicated, like to run a machine learning model, but they're useful. So if you want to just like predict something, you could use a Lambda with like TensorFlow. Well, not TensorFlow. TensorFlow is hard to get running on a Lambda. It's not really a good solution. But with like scikit-learn or something like that. If you just want to predict something and do a small amount of compute over and over on like a trigger, functions are good. Lambdas are good at that. They die after a short amount of time. So, and if your Lambda's timing out, you're basically doing it wrong. So it's a function you run without a server. Is there? And then Docker is containerized compute. So basically, you have like a little bit of a server. Like there's the core of a computer, and then you build just the bits you need in like these layers, and then you build your code on top of that, and you put that like in a box, and you can just ship that box to the cloud. And that means it's kind of the best of both worlds. Like an EC2 instance is flexible, and you can do all this configuration in Linux. Azure functions are hard to configure. Docker, you've got a lot of customization, but you only pay for the compute you use. So the task I was doing with my NLP project, right, reading data from Twitter and then doing some processing on it, is very bursty. Like if you look at the CPU usage, it goes like that. But I'm paying for that. Like not necessarily because of the compute credit thing, but basically I'm paying for a lot of downtime I don't need. If you've got, instead you can use Docker, is what I recommend with or Azure if it's not that complicated. Lambdas if you're using Python, it's not that complicated. But you can just pay for what you use. So you turn it on, it spins up super quick because it's like Docker's like a core of a computer. So it'll spin up, it'll run, it'll turn off when it's done. And that's a fairly easy thing to do, but it requires a high amount of skill. So I'd still recommend the thing I did. Start with like setting up your own servers and get used to that. I mean, the way I'd advise start with like Colab, like Google Colab, or like Azure SageMaker, or like Kaggle Cloud, right? If you're just playing around and want to do some data exploration in the cloud, start with that. Get Windows subsystem for Linux if you're on Windows. If you're on Linux, you already know Linux. If you're on Mac, start playing around with the terminal, get used to that. Learn the basics of Linux and the command line. That's a super like foundational thing if you want to do anything beyond your computer, because the internet runs on Linux, and the cloud is Linux, basically. So once you have that foundation, you have to build, and it's hard. You do all these packages, and sometimes it goes really badly. You can potentially put up a firewall on your server if you're not careful that locks you out permanently, and there's nothing you can do about it, right? That's what Linux is like. You can get it to delete itself. There's a learning curve there, but it's super useful, and it'll teach you a lot more about the computer, and you need it to do the infrastructure stuff.
Yeah, no, I think that makes a lot of sense. There's a lot to learn. There is quite a bit to it, actually. So, I guess when you're dealing with EC2, you got to, well, I guess you get gave a good example of when is a good time to use it, especially when you have AMIs, which basically there's these images which already exist. So you can basically just copy them on and start using them straight away. If you're sort of setting up and installing software, then, there's a lot that you need to add on top, right? So you need to maybe boot a computer, like basically set up an image, install all this software to get stuff going. That's where maybe something like Docker can be quite handy because you can have like all the sort of different pieces of software that need to work together, like all packaged together, that can just run. So that's probably one thing that's easier about Docker, is that you can package all the dependencies to make that work. The other thing is, as you mentioned, is that it's I guess easier to spin up and down, like a single container rather than this whole computer that needs to run all the time. I guess the only other thing that I would mention about serverless, like Lambda functions and everything, is that they are kind of really useful. So I mean, if you got like in terms of big, medium, small, I mean, you've got like a full computer, which is like everything. Then you've got Docker, which is like a kind of a subset of that, but still like all of the components to make everything work. And then you've got serverless, which is basically just which is just a function basically running in the cloud. So it's a bit like an event if you know programming and stuff, right? And so serverless is really, really lightweight. But the only thing about it as well is that it's also proprietary. It's the only other thing to mention that, if you're on Docker, you can kind of move between the different cloud providers, whether that's AWS or Azure or whatever it is. But with serverless, they're, basically Azure, AWS, they all have their own flavors of it. So you can't port those across the different systems. And so it is a very, very good and useful service. And a lot of the cloud providers will try and push that because, in some instances, it will save you money. It'll, be able to give you a ton of flexibility and performance and everything like that. But there is also vendor lock-in as well. So just something worth mentioning there.
It's also the other thing about like both Docker and Lambdas is that they're kind of parallelizable. It's like you're like function, like Lambdas are functions, right? So that same thing you were talking about with doing things in parallel. Well, the same thing applies here. So there's
really
a
good
trick
point.
with like single page applications now. So a lot of websites, you can just serve a website through a Lambda and like an HTML file and an S3, and that's like super simple, and it's just infinitely parallelizable. Essentially infinitely. Like eventually they'll run out of computers, but
yeah. No, it's really easy to scale, right? Because that's the whole benefit and beauty of the cloud, is that you don't have to be running on one computer. You can, run on one computer, you call a single function, and it can just as easily scale up to, say 100 computers or something like that, just as easily. So, that's the other real beauty of it. If you have like kind of spiky behavior, right? So, some really good points there. So, which leads on to, I had this question come up the other day, and I had somebody asking me about, whether they should bother building their own sort of, say, a powerful desktop machine or something like that for getting into machine learning. And instead of like maybe going to the cloud, because one of the things I mentioned is like, well, you either go to the cloud when your data is too big, right, to fit on a single computer, or if you need to share your data across either your team or with the world or whatever it is, that's kind of a key reason that you would move to cloud. But what if you're just developing it's neither of those situations? It doesn't make sense to say just to build out a dedicated machine learning computer at home or move to the cloud. I was wondering if you had any views on that.
Yeah, I mean, I think it really depends on. I mean, I'm not sure about the cost perspective. Like you are renting, and they are making money on it. So and I think that like at high utilizations, you can save money by building your own workstation, right? But a lot of it comes down to, and there's things like risk, right? Like if you accidentally leave a big GPU instance or big CPU instance running on AWS, and you leave it for like a week, you can be charged a lot of money. Like they're cheap
Yep.
for an hour, they're expensive for a week.
Yep.
Like if you're running it constantly for a month, it might be better. You might be better off buying a computer, like depending on like your use cases, right?
Yep.
So depending, like if you're working full time, then it might be better. You might be better off. I haven't done the maths on that, right? For me, a lot of it is about like ease of use. Was why back in the even just a few years ago, cloud compute wasn't that easy to use, but now with like Google Colab and like AWS SageMaker and like Kaggle kernels for like learning. It's really, and then there's a range of providers who offer Jupyter notebooks basically in the cloud on CPU or GPU for cents, microcents, even some of them, to get started. So if your budget is tight, then and your laptop is bad, then use the cloud. One of these providers, I mean, Jeremy Howard provides in his Fast AI course, provides in the first episode of that, provides some great options to use. Kaggle gives you free compute time. They even give you TPU, so they give you CPU, GPU, and TPU. TPU being tensor processing units, which is Google's proprietary deep learning chip unit.
Yeah.
Unit.
For tensor, I think. Yeah.
Yeah. Personally, I like computers. I play computer games. So when I was so what happened was my friend moved overseas and left me a 1U rack-mounted server with two massive old CPUs, which had like 50-something cores between them and like 50 gigs of RAM, something obscene. It ran for one glorious weekend before something broke, and it sounded like a jet engine. But I was using my old desktop machine, which had like an i5 with 4 cores and maybe 16 gigabytes of RAM or something, 16 gigs. And then I was trying to run some gradient boosted machines using like light GBM, and it was just taking ages. I'd leave it overnight and it still wouldn't have trained on the whole model. I used that thing and it was done in like an hour, and then it died, and I was like, okay, well, I like games. My games use processor, and it would make my home projects a lot quicker. And so I bought a Ryzen 9, and it's awesome. There's no doubt about it. Having like a really awesome computer is awesome, and boy, does Excel run great. It's so snappy. It's amazing.
Yeah, nice.
But that's the kind of thing that goes into it, right? Is how much do you like computers? Do you have thousands of dollars to spend on a top-end machine? Getting CUDA to work for your GPU, if you want to get GPU working, is super difficult. I mean, I haven't tried recently. I mean, for this NLP project, I'm probably going to give it another go, but I've tried several times, and each time I've lost an entire weekend and got nowhere. And you can just boot up a GPU image on the cloud and like run it for like not much money. So I'm still running like a relatively old graphics card in this computer for games. I would like to get it running on there, and if I can do it and if I can justify it, I might buy like a 1080 or a 2080, depending what the market's looking like. But realistically, you don't need one, I think, but it's nice to have. Yeah, and like modern laptops, I mean, modern Macs, right? They don't cool very well. So I don't know what the performance is like, but like data science tasks are extremely CPU intensive. So some of the people in my work, like some lead developers, they're throughout their career, their programs have been I/O limited, so they're limited by the amount of read and write from the hard drive. Data science tasks are pretty much all RAM limited.
Yeah.
right? Like RAM is something. If you've got a workstation, if you've got like a desktop and you're happy with it, or a laptop you're happy with it, then one thing you might consider doing that's pretty is it like an affordable option is put some more RAM sticks in it. You should do your
Mhm.
research, learn about that stuff. But if you're doing like projects, like having more RAM is just useful for like machine learning tasks and like data analysis. Because if you just ran out of RAM, you're in trouble. You have to like cut down the data set, and RAM's cheap. Um, but if you really want like a big, if you just like, yeah, most people watching this won't be deep learning researchers or like machine learning researchers, right? Or doing that. That's because not many people are, right? You wouldn't expect that. Um, so unless you're like using a extreme amount of compute all the time, and you don't work for a company like Google or Microsoft that has its own servers, right? Or a university that provisions that kind of stuff,
Yep.
or your company doesn't provide you with a workstation, um, then it's mostly, I think it's probably mostly about whether you like computers and whether you want a powerful computer. It's a
Yeah, I
good
think that makes
excuse
a lot
for
of
buying
sense.
a gaming PC, is what
Yeah.
I'd say.
Yeah, no, I think that makes a lot of sense. I mean, if you're into gaming, you were going to buy a gaming PC anyway, then yeah. Then one more excuse to like go off and buy your gaming PC because then you can also do machine learning on it and stuff, right? But if you're just, if you're asking the question and you're not really sure because you're trying to get into data science or something like that, probably the answer would be is probably not really that necessary. These days, like I'm assuming that most people these days, their primary computer would be a laptop. I mean, not necessarily, but generally, people are already going to have some laptop to do some work on. Um, and so going off and buying a dedicated kind of big box and everything like that uh, to do some machine learning workloads is an additional expense, right? And if you're not sure about it, if you're not sure like how much compute that you're actually going to be using, then maybe it does make more sense just to push that to the cloud because you are effectively renting that. I mean, you mentioned a whole bunch of great resources as well, like Colab and everything like that. I mean, you can get started for free even, right? So you don't even need to pay anything to start experimenting with those. And then even if you were paying for it, like you mentioned, right? It's cheap by the hour, but expensive by the week, right? So um, making sure you keep an eye on that. But if you're experimenting for like a short periods of time, then because the thing is this, right? You're building out a model, you're coming up with ideas and hypotheses, you're tweaking your code. There's a lot of time doing like all of those things, which you can all do like locally on a laptop before you need to actually run your experiments and take up a lot of compute time, right? So you don't necessarily need to be paying for a lot of that time. And the thing is that hardware, I mean, if you get a high-end GPU, they're really expensive. I mean, you can spend like a couple of grand on like a high-end GPU, right? So these are not cheap. They're really, really expensive. Like most things, probably the price will come down, and that would be, I guess, effectively the other benefit of renting, I would say, right? Because you can rent something, use it now. There's no maintenance or anything on these servers to do. Like in a year's time, you're renting the newest, latest GPU a year from now, and a year after that, and a year after that. So that's kind of really the benefit. Like like you said, unless you're maybe into something like gaming, unless you are starting to rack up more costs on these cloud service providers, and you want to limit that because you really do have something which is like running all the time, and that you would pay that back within, if you were going to pay that back within the year or something like that, then yeah, maybe it makes sense. Otherwise probably not, right?
Yeah, I mean, and it's kind of great, right? And the barriers to entry for this to data science is real low these
Yeah.
days. Like realistically, if you have a functioning laptop, even if you've got like a Chromebook, you can do data science, right? And that's really great. Yeah.
Yeah. No, I mean, I did make a video about this actually, and yeah, like you mentioned, with things like collab and doing compute on the cloud, you can do a lot of those things. I would say that it is a lot nicer and easier to do stuff locally if you can. I mean, it's just well, I don't know. There's a lot of things which are easier, like like say you're working with Excel, right? As well, and you just want to have some of those things. You just probably want to have some of those things locally to be able to do those
I
kind of
mean, yeah,
things.
that's the thing, right? Like I'm thinking of this from like perspective of someone like learning
Yeah.
and doing it on their own time. If you're in an office and you're forced to use Windows, then yeah, and you don't have access to the cloud, then yeah, you need a workstation, right?
Mm.
But and if you're at a company, then it's a different matter. But but my thinking is, if you're just like trying to get into data science, or you're new to it, or you're looking to progress further, then the cloud is a really great way of getting into it. And the big thing is Windows, right? Like I don't think anyone's buying super powered Apple. I mean, some people might be buying a Mac Pro, but most people will be buying will be on Windows, right? And so a good reason for sticking, if you really don't want to learn Linux and how to like deal with cloud infrastructure, and you want to do something slightly more complicated than Google Colab, then maybe the cloud's not a good option. You should buy a workstation. But I mean, I really think people should learn Linux and learn how to do it. You'll learn a lot about computers, and it's open source, right?
Yeah.
No one can take that. No, yeah, you'll always, yeah. Computers are foundational to a society, right? So you should be able to run a free operating system, a free and open source operating system, because then you're not beholden to Apple or to Microsoft for your compute needs.
Yeah, for sure. And just to clarify as well, I mean, do you use Mac, Windows, or Linux for
All three.
all three?
This is a Mac laptop, which I got in 2013. It's very nice,
Yep.
still very nice. It's starting to become obsolete. Not sure I'll buy a new one, new Mac, because they're not doing a good job on cooling. And yeah, the engineering of their laptops is not really kept up. And it's looking like maybe Surface Books and stuff are looking very attractive. I have Windows and Linux dual boot on my workstation here. I've got a bunch of old PCs in there, which I have Linux on, that I used to use for. That's the thing. So I've done a lot of projects using like local servers, but it's easier to use the cloud in that case. And then on Windows, I've got Windows Subsystem for Linux, which covers basically all my needs. The only reason I would use my Linux boot these days mostly is for Docker, because you need Windows Pro for Docker on Windows, but on Linux and Mac, you don't.
You can put Docker on WSL as well now with WSL2.
Is that a thing?
Yeah.
I haven't looked recently. That's something I've been very. Yeah,
It's
awesome.
very recent. It's very recent. So WSL2, they only just finalized it within the last month or so.
I haven't checked the news on that. That's awesome. That's awesome. Great. Who needs a Linux dual boot anymore then? Apart from, but I mean, seriously, Linux is really cool. And when you get to dig into it, there's things like i3, and you can have like tiling window managers, and there's a bunch of deep nerd stuff you can get into. If you're really into computers, you can do some interesting stuff and like make your perfect operating system. But at the same time, I don't know why my front sound port doesn't work on Linux.
Driver issues, driver compatibility issues is going to be issues.
Yeah, and I spent 2 hours doing it, and then just used the other port. But yeah, it can be a bit annoying. I mean, I've moved that Linux boot between like 4 different computers at hard drive, so I'm kind of not surprised that it doesn't work. And I could do a rebuild, and maybe I will. And there's some cool new flavors of Linux these days, that people are into. But and like there's things like Alpine. There's a whole world of Linux, and it's exciting. But I use Linux in the cloud. That's primarily where I use it. I've been using Ubuntu for my Docker images, and I'm probably going to switch to Debian because it's got like wide support and it's much smaller. Ubuntu's got a bunch of bloat. But yeah, I use all of them.
Bit of everything.
Bit of everything.
Anyways.
Yeah.
So I think we should probably wrap things up. I mean, we've had a fantastic, pretty long, little geeky conversation here, which I've really enjoyed a lot. So really, really appreciate your time, and should probably get going. So
Yeah, it's getting pretty late. I mean, clearly I've been enjoying it because we've been here talking for 2 hours, and it's getting quite late.
yeah.
But this was good. Yeah.
All right. Cool. Well, thank you for your time, and we'll catch up another time.
Yeah, sounds good. Thank you for yours, and yeah, it's been a really good conversation. Take care. Have a good evening.